Project 2.4, Unpacked, the 555 timer. This project dives deeper into the 555 timer by exploring it at multiple levels. The first is a standard 555 oscillator, which serves as the baseline for understanding the timer's functionality. Next, we replicate the 555 timer using an LM358 dual op-amp, NOR gates, and inverters. Finally, we push the boundaries further by constructing a 555 timer out of transistors. Together, these three circuits provide a layered understanding of how the 555 timer generates its signature square wave output. The first circuit built in this project was a simple 555 oscillator using the timer in astable mode. In this mode, the 555 timer continuously generates a square wave, alternating between high and low states without requiring external triggering. The 555 timer operates with two comparators that monitor the voltage across a capacitor, comparing it to reference voltages at 1/3 and 2/3 of the supply voltage. The comparators trigger an SR latch, which controls the output stage of the timer. This process generates a continuous oscillation with the frequency of the square wave determined by the timing resistors and capacitors in the circuit. This is determined by the following formula: frequency equals 1.44 over R1 plus 2R2 times C. The second version of the 555 timer was built using an LM358 dual op-amp to replicate the internal comparators of a 555 timer. A voltage divider was used to create 1/3 VCC and 2/3 of VCC reference points, guiding the LM358 op-amps as they are monitored by the capacitor's voltage. When the voltage crossed these thresholds, the comparators triggered an SR latch constructed from a NOR gate, which controlled the output state. To ensure a clean, stable square wave, an inverter was added to strengthen the final signal. This version of the 555 timer successfully mimicked the behavior of the original IC, generating a clock signal that was used to drive the counting circuit. The third and most challenging version involved constructing the 555 timer entirely out of transistors. The voltage divider consists of three 4.7 k ohm resistors in series between VCC and ground, generating the reference voltages. These voltages set the thresholds at which the comparators trigger the flip-flop, controlling the timing of the square wave. The trigger comparator is built using four PNP transistors arranged in pairs. The emitters of two transistors are connected, and a 10 k ohm resistor is placed between this junction and VCC. The bases of these transistors are connected to the emitters of the two following transistors, whose collectors are grounded. When the capacitor voltage falls below 1/3 of VCC, the trigger comparator will activate the flip-flop by pulling the base of the transistor connected to the flip-flop set input low. The threshold comparator is constructed using four NPN transistors arranged similarly to the trigger comparator but reverse polarity. When the capacitor voltage exceeds 2/3 of VCC, it resets the flip-flop by pulling the reset input low. The flip-flop uses two cross-coupled transistors. When the trigger comparator activates, the flip-flop is set, producing a high output. When the threshold comparator triggers, the flip-flop is reset, producing a low output. The output stage uses a pair of NPN and PNP transistors with the emitters connected to ground and VCC. These transistors act as switches, toggling the output between VCC and ground to drive the LED and generate a square wave signal. Each section of the circuit uses transistors to mimic the functionality of a 555 timer. The comparators trigger the flip-flop, which controls the output, and the output stage drives the LED. Overall, this project provided a layered exploration of the 555 timer, starting with its standard operation and progressing to custom-built versions using op-amps and transistors. The LM358 base timer offered a detailed look into how comparators, voltage dividers, and latches work together to replicate the 555's behavior. The transistor-based version, while immensely challenging, revealed the fundamental principles that power the timer at its most granular level. This is Project 2.4, Unpacked, the 555 timer. Thank you for watching.